Yes.
Okay. Is there anybody whose name I didn't call? Hold on, let me see. Okay. Is Theo here? Kat Turner is not here. Natalie Gregory is not here. Christina.
She's playing game.
Nyasha. Okay. Just making sure, you know, your financial aid depends on it. I don't want to mess your life up. Okay. So let's get started. Let's get started. Okay, so today we are going to study chapter 3. Last week we studied chapters 1 and 2. How many of you are not registered for Connect? Raise your hand if you're not registered for Connect. Can you hear me?
Yeah.
Okay, if you're not registered for Connect, raise your hand. Is everybody registered for Connect? Okay. So if you're not, please make sure you do as soon as possible, okay? Weird, like I think the closer you get to the receiver, stronger. You know, there's something in electronics called automatic gain control. It doesn't have it. Technology from like 1970s or 60s. Okay, so let's get started. Chapter 3. Okay. Now let me ask you a question. If I say elastic, what do I mean? Like when we say something is elastic, what do we mean? Change. Change is a very good word, but is it just change? Is our change and elastic interchangeable? I gotta stay away from that receiver. That's my automatic gain control. I walk away from it. Oh, so, for example, let me ask you this: is it elastic? We say an elastic band, right? But we don't say steel is elastic. Why do we do that? Which one could be changed more, steel or the band? Steel can be changed more, actually, right? You could take a bar of steel, convert it into miles of cable or wire, okay? So change cannot be elasticity. Elasticity is a little more than change, okay? Now, so here are our learning objectives. Like I'll explain in detail what elasticity is. Now, tonight we are actually going to study basically elasticity with respect to the demand curve, okay? Different types of elasticities, but they're all with respect to the demand curve. There's no supply elasticity that we are going to study tonight. Now, what is elasticity? You know, in general, the best way to define elasticity is to define it mathematically, right? So elasticity is percentage change in one variable, like let's say A, when a variable that is related to or that affects it, B is changing. Okay? Now, mathematically, this is in the form of a ratio. Now, So basically, you can interpret that formula as follows. For every 1% change in B, how many percentage points A change? For example, if B changed by 10 percentage points, and as a result, A changed by 20 percentage points, elasticity will be positive, okay? Not the first elasticity we're going to study is actually negative, okay? It need not be positive. This is just an example for some variables A and B that are related in some relationship. Of course, then you might ask, what is that triangle? Okay, so this triangle is the Greek letter delta, and it stands for change. So when you read this, you read it as percentage change in A divided by percentage change in B, okay? Or percentage change in A per 1% change in B, okay? Now, what kind of elasticities are we going to study? Actually, before we get to that, I want to expand on this formula. I want to show you what percentage change is. Okay, so let's say that is change in A divided by A times 100. Okay, now what is change in A? Change in A is computed as the new value of A minus the old value of A. Okay. So for example, if A goes 30 from 20, what will the percentage change be? Let's compute the percentage change in this case. So what is the change? Change is the new value minus the old value. It's going to be 30 minus 20. Of course, here you might want to add like this is the old value. So I divide it by 20 and multiply it by 100. Okay? So that's going to be 10 divided by 20 times 100. So that's going to give me 50%. Okay? Any questions so far? Okay, now we know actually how to compute percentage change for a variable. Okay? Elasticity is just the ratio of two percentage changes. Now, the first type of elasticity we're going to study is called the own price elasticity. Okay, own price elasticity. And it's going to be computed as follows. The book uses, I'm just going to put like EP X, X being the good in question. Okay, it's going to be percentage change in quantity demanded of X divided by percentage change in price of X. Okay. Now, let's do some algebra actually. You know, let me skip the algebra because I don't want to fill like 2 pages with algebra, and I'm sure you're not big fans of algebra. But let me give you this. Draw the demand curve here. Does anybody know what slope is? Of course you do, right? What is slope?
Steepness of the line.
Who said that?
Yeah.
Who are you?
Kevin.
Excellent. Did I teach you in a class that you took from me?
No.
Wow, I'm very impressed. Okay, so slope will be change in the y variable, in this case, divided by the change in QD. Okay, for the demand curve, that'll be QD. Now here, elasticity, if you manipulate this and do the algebra, it'll be 1 over the slope times so 1 over slope basically will be change in QD divided by change in P times P over Q. Okay? So like I skipped a bunch of algebra, but I'm not here to teach you algebra. Now that elasticity is 2 parts. Okay, that elasticity is 2 parts. There's this part, which is 1 over the slope. And then there's this second part. Let's talk about what they mean. Okay. I don't want you to be memorizers, like, just don't memorize stuff. Try to understand what they mean. Okay. Now let me ask you. And Kevin said slope measures steepness, right? That was an excellent answer. So what does 1 over slope measure then? So slope measures steepness of a function. What does 1 over slope measure then? Thank you. That's actually a very good realization. That's excellent. So what is the inverse concept of steepness? What's the opposite concept of steepness? If something is not steep at all, what do we say? Flatness. Thank you. Thank you. So did you hear that? Steepness, right? What is the opposite of steepness? If something is not steep, if a mountainside is not steep, what will we characterize it as? Are you following my question? Did you hear it? So what is the opposite of steepness? If a hill is not steep, it is relatively
Flat.
flat. Thank you. Who said that?
Me, Daniel.
Daniel, very good. Excellent.
Thank you.
Okay. So the first part, this is the inverse of slope or the reciprocal. What do we call it? We call it flatness. So the first part will be large for a demand curve that is flat, because here we are talking about the steepness of the demand curve. Okay. Of course, this is the inverse demand curve, but that's totally fine. This is the inverse demand curve. 1 over its slope goes into elasticity. Okay. So this is basically the slope of the demand curve itself. This slope is the slope of the inverse demand curve. You have to be careful. So elasticity, first part, in a sense, is flatness of the inverse demand curve. Okay, inverse demand curve. For example, if I have 2 demand curves, I call this one D1, I call this one D2. Which one is flatter? D2. This quantity in absolute value will be larger. Of course, you have to be careful. Remember, the slope is negative, right, for the demand curve. So this number will be larger in absolute value, okay? So D2 is flatter. Its slope is less. You divide 1 by a smaller number, but a smaller negative number. That makes it a large negative number, okay? In absolute value, it's larger, but as a negative number, it's small. Because the more negative something becomes, it's small. Okay? So this is the flatness part. What is the second part measure? So the elasticity is related to 2 things. Here is part 1, and here's part 2. Okay? There are 2 things or 2 ingredients that goes into what makes up elasticity. What does the second part measure? P over Q, what is that? That's a good realization. Mathematically, that's an interpretation. But like if you wanted to have a geometric interpretation, what would it be? That'll be for Q relative to P. It'll be actually where you are on the demand curve. Excellent. I take off my hat to you, actually. Are you an engineer? That only engineers can see that. Okay, that's, you know, like, that's amazing. I take that back. You know, for those of you who are not engineers, I apologize for non-engineers. That was a joke. Okay, so did you hear that? You know, the second part is actually, you know what? Let me ask you, maybe you did not hear it. So, Jefferson, what does the second part measure? Or what is its interpretation geometrically? How will you, what is P over Q geometrically? How does it relate to the demand curve? Any idea? Let me give you actually numbers, like, you know, you can always simulate your environment. So let's say we pick up D1 and this number is 10 and this number is 5, right? That means you have the slope of -2. Okay, so if you pick up the midpoint, this will be 5, this will be 2.5. Okay, let me call this point A, let me call this point B, let me call this point C. Now at point A, B actually, let's say, you know what? So at point A, right, what is P? What is Q? 0. But let's pick up a point that's a little down from A, right? Because otherwise we'll be dividing by 0, right? So we'll be doing something like 9.5 divided by 0.5. Okay? So what does that give you? Like a point right here, like point D, right there. That gives you what? That gives you 19. Okay? Go from D to point B. So at point B, what is the P over Q ratio? It is 5, right? Over what? 2.5. What is the number? 2. As we went from D to B, what happened to the P over Q ratio? It went down. It went down. So what does P over Q measure? It is a number that gets smaller and smaller as you move down the demand curve, right? But in general, what is it measuring? It's measuring your, in a sense, like in human language, not mathematically, in English in this case, one of the human languages. What? Excellent, excellent. Did you hear that? Jefferson, do you have an answer yet? It's almost like a Price is Right kind of competition. Did you hear the answer?
No.
Do you have an answer? Okay. He said, go ahead, I'm listening.
The middle point, no?
No, no, what does P over Q measure on the demand curve?
Huh?
What does P over Q measure on the demand curve? You know, Knoxville said position, and I completely agree. You could call it position, you could call it location, okay? Literally, that number measures your location on the demand curve. If I said P over Q is infinity or negative infinity, you'll be at point A. If I said it's 0, you'll be at point C. If I said it's 2, you'll be at point B. No ambiguity. Once I know that number, I exactly know where on the demand curve I am. It'll totally pinpoint you to an exact point location. Okay? Almost like GPS, like it'll give you your coordinates on the curve. Okay? Every coordinate here has a one-to-one correspondence to that ratio. Okay? So part 1, flatness. The second part, location. Your elasticity value depends on 2 things. How steep your demand curve is, or how flat it is in this case, or where on the demand curve you are. Okay? Let's give some extremes. Let's cover some extremes. Let's pick up a flat demand curve, okay? So this is quantity demanded, this is price. What is elasticity on this demand curve, okay? So Number one, what is the slope of this demand curve? What is the slope of a flat demand curve? What is slope? Changing P divided by changing Q in this case, right? Because it's rise over run, right? Now, in this case, if you move from point A to point B, let's say this is 2, this is 1, and this is 2. So if you move from A to B, right, how much is your price changing? What's the change in price from A to B? 0, right? Because price is 2 at both points. How much is your Q changing by? New value minus the old value, 2 minus 1. That is 1. 0 over 1 is 0. So what is the slope of a flat demand curve or a horizontal demand curve? 0. Then remember your elasticity, right? Price elasticity of demand, let me put it here for X, is equal to what? 1 over slope times P over Q. Okay, let's pick up a point. Let's compute it for point A. Okay, so what is 1 over slope? It's like kind of 1 over 0, right? What is 1 over 0 mathematically? Or if you approach 0, you get close to 0 as the number in the denominator gets smaller and smaller, right? Which is what the slope is here going towards 0. What happens to that ratio, the first part? The first part goes to infinity. In this case, actually, since it's approaching from negativity, it goes to negative infinity. So the first part becomes negative infinity. The second part, would it matter what it is? Let's pick up point A. At point A, P over Q is 2 over 1. At point B, it is 2 over 2. So the second part doesn't matter, right? Because this ratio is 1, this ratio is 2. Either one, you multiply it by negative infinity. What do you end up with? Negative infinity. So what is price elasticity of demand for a good X, which has a horizontal demand curve? What is the price elasticity of demand? Negative infinity. What do we call that in language? We call it perfectly elastic. Perfectly elastic. Okay? Does that all make sense? Jefferson, you can follow, right?
Yes.
Yeah.
Okay. If you have questions, please ask. Okay. So this was one extreme. Let's give another extreme. So here's another demand curve, which is an extreme. This one is vertical. Okay, this demand curve is vertical. Elasticity, price elasticity of demand for X is again 1 over slope of this curve times P over Q. Now let's give some points. So here, let's say we pick up point A, and this price is 5, and pick up point B, this price is 2, and this is 3 less. Of course, we have the origin 0, 0 coordinates. Now, what is the slope of this curve? Remember, slope is change in P divided by change in Q between 2 points, right? If you go from A to B, right, what is the change in P? It's -3, right? Because it's declining, right? Excellent. And what is the change in Q? Q is 3 for both points, right? It is 0. So what is the first part? Negative infinity. Thank you. Are you a mathematician? Awesome. So how about the second part, P over Q? At point, let's pick up point A. At point A, this is point A. At point A, what is P over Q? It is 5 over 3, right? At point B, what is P over Q? 2 over 3. Okay. Oh, we made a mistake. This is the slope. We have to take the 1 over slope. So what is 1 over slope? 1 over negative infinity, right? This goes to 0. 0, because we're not computing slope. We have to put 1 over slope in there. Okay, so there are two possibilities for this. One of possibility is 5 over 3. The other possibility is 2 over 3. If you multiply 0 by 5 over 3, what do you get? Exactly. If you multiply 0 by 2 over 3, what do you get? 0. In either case, what is the price elasticity of demand in this case? 0. So a vertical demand curve has 0 price elasticity of demand. Okay, that's one extreme. And the previous one was negative infinity for the flat or the horizontal demand curve, another extreme. Okay, now here's some terminology. Let's cover some terminology. And this one, what do we call it? The previous one, we called it perfectly elastic. This one, we call it perfectly inelastic. Okay, this is called perfectly inelastic. Okay. Now, here's some more terminology. Here's the range of values the price elasticity of demand can take. Of course, I should not have done that. I can put this like this. So you start at negative infinity, you go to 1, and then you go to 0. It can never be above 0. Okay, that's impossible. We proved two extremes. It goes between negative infinity for a horizontal demand curve to 0 for a vertical demand curve. A demand curve always has to have negative slope, right? So elasticity will always be negative. Why? Because the second part, P over Q, is always positive because P and Q are positive, or at least non-negative. And the first part is always negative because of the law of demand. So this portion of the elasticity spectrum, we call it elastic. Okay? And this, we call it inelastic. And here, exactly at negative infinity, we call it perfectly elastic. And this one, we call it perfectly inelastic. Okay? Okay. Now, let's continue. Now let me show you something else. The book sort of covers it, but there's not enough detail, okay? This is the midpoint, okay? And then I still have quantity here. This is what quantity demanded. But here I'm going to put total revenue. Okay, total revenue. Now, what is total revenue? From your micro classes, it's price times quantity. In this case, price times quantity demanded. Okay? Now, at this point, let's call it point A. Let's call this point B. Let's call this point C. At point A, what is price? Price is 20. Okay? At this point, oh man, allergies. So price is 20. What is quantity? 0. 20 times 0 is? So total revenue is 0. The point A here becomes point A here. Okay? Now, how about at point C? What is price? 0. What is quantity? 10. 0 times 10 is again 0. Again, total revenue is 0 at point C. Okay. Let's pick up point B. What is price at point B? 10. What is quantity? 5. 10 times 5 is 50. Okay. So what point is this? This is point B. Now let's pick up a point in between. Right in here, right? What is this point? 15, midpoint between A and B. And this is 2.5, right? 15 times 2.5, what is that? 37.5. So it's less than this. It's somewhere here. Okay, that's what total revenue is. Let's call this point D. And let's pick up the midpoint between B and C. Let's call it E. At that point, price is 5 and quantity is 7.5. 5 times 7.5 again is 37.5. Okay, so this kind of is a symmetric function, the total revenue function here. Now, if you draw it and you keep doing the same exercise, you'll end up with a function like this. It's nonlinear, but it's symmetric around the midpoint. Okay, this is 2.5. This is 5. This is 7.5. This is 10. Of course, this is 0. Doesn't look like either one. Now, what are we doing here? If I wanted to compute elasticity at all these points, right? At point A, we already know the elasticity value, right? What is the elasticity value at point A? Let's compute it. It's going to be 1 over slope. What is the slope of this curve? The slope of this curve is 20 over 10, -2. Negative, of course, if you're going this way, it'll be -20 divided by +10, which will be -2. So it'll be 1 over -2 times P over Q. At point A, what is P over Q? It's 20 over 0, right? So that's infinity. So -infinity in this case, or infinity in this case. So because price over Q is positive, right? So what will it become? It'll become -infinity. So at point A, what is the price elasticity of demand? -infinity. Okay? It's almost like the extreme we saw with the flat horizontal demand curve. For the nice negatively sloped demand curve, only at one point you have -infinity elasticity. On the horizontal demand curve, you have it at every point. Okay, that's the difference. On this, -infinity happens only once, only at one point. Now let's compute elasticity at point C. It's going to be again 1 over -2, but at point C, what is P over Q? P over Q is 0 over 10, which is 0. So what is price elasticity of demand at point C? It is 0 at this point. Now, how about at point B? It's going to be -1 over 2 times P over Q. What is P over Q? 10 over 5, 2. -1 over 2 times 2 is -1. If you go through this exercise, you'll realize, so elasticity here is -1. You'll realize the upper section of the demand curve, because you could do it for DNA, and you'll realize this portion is elastic. Elasticity is between -1 and -infinity. Now, and in this lower portion, it's inelastic. Elasticity is between 0 and -1. because you can keep doing it at point D and E and it'll confirm. You can populate it with more points. It'll always be the same. Any questions? Now, here's one thing. What if I'm given a demand curve, right? Like sometimes you compute slope from 2 points. Sometimes you get the slope from the demand function itself in algebraic form. So if you have, like, for example, P equals 20 minus 5Q, okay? Then remember, the slope we were talking about was what? It was the slope of the inverse demand curve. It's change in P divided by change in Q, okay? In this case, what is that value? -5. Thank you. Are you an engineer? I'm surrounded by engineers here. That's awesome. Okay, so in this case, this will be 20. This will be 4. Okay, and makes sense, right? Oh, my 20 doesn't look like a 20. Okay, one is like the visually or graphical representation. One is the algebraic representation. You could get the slope from either one. Okay. Now, sometimes they might give you this and ask you to compute elasticity. Don't get confused, right? Same exact logic applies. For example, if I wanted to compute elasticity at this point, okay, this is 10. And what is this? This is 2. It's the midpoint, right? And let's call this point B. Let's compute elasticity in this case for good X. This is quantity of X at point B. What is it equal to? It's equal to 1 over slope again, same formula, times P over Q. But in this case, P at point B, Q at point B. Slope is the same at any point. Why? Because it's a line. Slope is constant. So what is 1 over slope? 1 over -5 times P over Q. P at point B is 10. Q at point B is 2. They cancel out. This becomes 5. 5 divided by -5. What does that give you? -1. Okay. Always at the midpoint of a linear demand curve, elasticity is equal to -1. By the way, what do we call -1 elasticity? We call it unit elastic. We didn't write that here. So this one, we call it unit elastic. Unit from uno Latin, meaning 1. Okay. Now, let's go back to this graph and learn one important fact. Why is the book like covering this? Let's make that a little clearer, okay? So the book does not draw total revenue, but let me talk about this in a little more detail. So now, as you all can tell, between 0 and 5, right? Quantity on the demand curve. Which section? It's the first section, right? 0 to 5 quantity. What are the elasticity values? 0 to 5 quantity corresponds to prices between 20 and 10, right? In that range, elasticity is, demand curve is elastic, right? It's between -1 and -infinity. So when demand is, you should pay a lot of attention to this statement, the next statement, okay? You know, when demand is elastic, what does that mean? I'm talking about the upper section, upper half of the demand curve. An increase in quantity, meaning I'm moving in this direction, leads to what? leads to an increase in total revenue. Leads to an increase in total revenue. Let's do it again. When demand is elastic, meaning I'm in the upper section of the demand curve, and increasing quantity, meaning I'm moving in this direction, lowering price, increasing quantity, right? As I move towards from here to here, what happens to my total revenue? It goes up because quantity is going from 0 to 5. At 0, total revenue was 0. At 5, total revenue is at maximum 50. Okay? Does everybody follow? So when demand is elastic, total revenue and quantity are positively related. When demand is inelastic, on the other hand, inelastic, the lower half section of a linear demand curve, and increasing quantity leads to a decrease in total revenue. So when demand is inelastic, total revenue and quantity are inversely related. Okay? Or you could state the same facts in terms of the relationship between price and total revenue. And quite often, that's how they are stated. Let's do that too. When demand is elastic, as you increase quantity, you are lowering price. Price is going down, total revenue is going up. So when demand is elastic, price and total revenue are inversely related. Total revenue and quantity are positively related, but price and total revenue are inversely related. And that is from the slope of the demand curve, right? Because price and quantity are inversely related. Now, when demand is inelastic, meaning I'm talking about the lower half of the demand curve. What is true? As I increase quantity, I'm reducing price. Price is going down. Price is going down. As quantity increases, so is total revenue going down, right? So when demand is inelastic, price and total revenue are positively related. Okay? Because they're both going down. If two variables move in the same direction, they're positively related. If they move in opposite directions to each other, they're inversely or negatively related. Okay? Any questions? Now, I want to add something to this graph, and you have learned this concept in your microeconomics classes. It's the concept of the marginal. We talked about it a little bit last week. Now, for a function such as total revenue, right? Marginal revenue is going to be its slope. So the concept of the marginal for a function gives the slope of the function. And how do we find the slope of a function? We find it as its tangent slope, right? At a point. So in this case, you can draw the marginal revenue curve on the demand function. For a linear demand curve, it's going to be twice as steep as the original demand curve, and it goes into negative values in the inelastic portion, and it's positive in the elastic portion, okay? That's what you're seeing here. So if the slope of the demand curve is equal to -5, what is the slope of the, in this case, actually, for this demand curve, this is not the other one. This is the first one we did. What is the slope of the inverse demand curve? It is 20 over 10, of course, -2. So what is the slope of the marginal revenue curve? It is -4. Why? Because it's 20 divided by 5. Of course, don't forget the negative sign, okay? So never forget, the marginal revenue curve is always twice as steep as the demand curve. Now, what does that mean? Whatever the slope of the demand curve, which is a negative number, marginal revenue slope is going to be twice that as a negative number. So if the demand curve slope is -5, marginal revenue is going to be -10. If the demand curve slope is -20, marginal revenue is going to be -40. We talked about all this. Now, okay, cross price elasticity. That's a new concept. Hey, let's take a 5-minute break. We come back with cooler minds, and then we continue. Okay, 5-minute break. Any questions? Yes. I'm listening.
Okay, so in the connecting,
Yes.
everyone is in the class of summer 2020, but I'm in the
I know. This is
2021. I have
yes. No, yours is
to do the homework.
yes. Having two classes is a problem.
No,
Having two
like in my connect, I have the two classes, but I don't
yes, that's a
homework.
problem. You know what that does? If you show up in two classes, your grades do not transfer to Canvas.
What?
Yes, your grades will not transfer to Canvas. I'll have to put them manually. This is a problem with Macro Connect. Now, Macro Hill Connect.
My question is, which class do I have to do the homework of?
Okay.
The 2020 or the 2021?
Which semester are we in? Spring 2021, right?
Yeah, but everyone else is in the 2020.
I know. It's because Macro Hill Connect doesn't know which semester we are in. I create the class for spring 2021. They end up registering all my students in the fall section or the summer section. In this case, summer section of the same class. So please call. Actually, you know what? I'll manually correct that. You guys don't worry. Okay.
But the homework is different from both.
I know all those problems. I'm going to address them. Okay. I'll send you guys an email for a solution.
Okay.
They're unable to solve them usually, but you know, it's a very sad situation. I might have to create a third section and everybody has to move to it, but I don't know. I'm going to solve that problem because
Okay, thank you.
they have been having this problem forever.
Okay.
Okay.
Yes.
Thank you for bringing that to my attention.
Okay.
Okay, let's get started. Now, what's the price elasticity of demand?
So yes, but I have 2 homeworks for each chapter.
Have you noticed this formula is a little different, right? The price of Y is changing, but we are looking at the response for the good X. So what if, so here's an example. If I change the price of gasoline and look at how quantity responds as a result, that is price elasticity of demand for gasoline. But if I change the price of electricity or natural gas, a different product, and then look at what happens to the quantity demanded of gas, that is cross price elasticity. So the price change is for another good that is related to this good, either a substitute or a complement. Remember, when we were studying the demand curve, we said, like, you know, quantity demanded is not only affected by the own price, but it's affected by the prices of other goods, which may be substitutes or complements. Here, you're changing the price of a substitute or a complement, and then you are looking at how that changes the quantity demanded of this good in question. Okay? Now, the percentage change in quantity demanded is for X. But where is the price change coming from? From Y. Okay, the price of the other good. That other good could be a complement. That other good could be a substitute. It might be a good we use in place of this good, or it could be a good we use together. Like peanut butter and jelly are complements. But peanut butter and Nutella are substitutes. So for example, if I change the price of Nutella, okay, by 5% points, okay, plus 5, let's say. I increased it by 5%, right? What will that do? People will, by the law of demand, buy less Nutella, right? But as a result, what will they do? They'll buy more peanut butter, okay? So this will be something like plus 10%, let's say, okay? And the good here is peanut butter. So 10 plus 10 divided by plus 5, what does that give you? Plus 2. So if the cross price elasticity of demand is greater than 0, as your PowerPoint says, as I proved here, then you have goods that are substitutes. Okay. What if I picked up a complement, right? the price of jelly, let's say I increase the price of jelly by like 6%. Okay, so percentage change, price of jelly is equal to +6. That means I increase the price of jelly by 6%, right? How is the quantity demanded of peanut butter going to respond? Okay, if I make jelly more expensive, people buy less jelly by the law of demand, right? As they buy less jelly, it is not as much fun to eat peanut butter without jelly. So what's going to happen? Let's say this decreased by 12%. So what is the ratio? So if I divide the -12 by +6, what do I get? -2. Every time I increased the price of jelly by a percentage point, the quantity demanded of peanut butter went down by 2 percentage points. Okay? It led to a severe decrease in the quantity demanded of peanut butter. Okay? So when the cross price elasticity of demand is negative, you automatically know the goods are complements. The original change was created by the price of a good, which was a complement to the good in question. Okay? Now here's here's a formula. You know, I think I'm going to take out this formula, but you know, if I were to explain to you what we are looking at how the revenue of a company changes as a result of a change in the price of X when they are actually selling two products. Okay? So the price change is coming from one product only. But since they are selling another good that is related, it's leading to revenue changes from both sources. Okay? Remember, through the cross price elasticity. That's what this formula is about. I think moving forward in my homeworks, I'm not going to ask this question. Okay, income elasticity. Here is another elasticity concept. This time, the denominator has the percentage change in income. Okay, so income elasticity of demand equals the percentage change in quantity demanded, just like usual. We are interested in how much quantity demanded changes in percentage terms. But this time, the source that is causing that change is income. What if I increase your income by 10% points? So this will be +10. As a result, if you bought 20% more of good X, your income elasticity for good X will be +2. If this elasticity is positive, the good in question is normal. If it is negative, the good is inferior. Okay? Some goods are inferior. As our incomes go up, we buy less of it. So the sign of this elasticity will tell you if the good in question is inferior or normal. If the income elasticity for a good is positive, that means the good is normal. If it's negative, that means the good is inferior. Okay, there are other elasticities. You could have advertising elasticity. You know, commercials for a good affect your quantity demanded. You know, the more money a firm spends on advertising, they're going to change your quantity demanded through it, right? Through which variable? Through taste and preferences. You know, advertising changes your taste and preferences. You know, if you got news through an advertisement or through a commercial that said like orange juice is good for your heart, okay, that's going to change people's tastes and preferences, and people are going to buy more orange juice. Or there could be cross advertising elasticity. Advertising is done on the complement or the substitute good, and we are looking at how that affects the price, the quantity demanded of this good. Now let's give an algebraic form of a demand function and from it compute some elasticities, okay? Or cover all these elasticities we just learned about. So here's a demand curve. And if you look at that functional form, right, you have to be careful. What is the dependent variable? The variable on the left-hand side, right? Remember, when we draw the demand curve, how do we draw it? We draw the demand curve as? We draw the demand curve, of course, negatively sloped in either case, but we draw the demand curve as P on the vertical axis. Classic Microsoft. You go from page to page, it changes its settings. Seriously, it forgets that I always choose that. I mean, what century are we in? When you're a monopoly, you never have to change. Okay, so remember, this is the usual representation of the demand curve, right? You never see a demand curve that does this. Okay? That's not like supply and demand. That's an X. We don't see demand curves that look like this, right? You know, quantity on the vertical axis, price on the horizontal axis. Now, for a mathematical function, the variable on the left-hand side of an equation representing a function is always going to be variable on the vertical axis. That's like the convention, you know. But if you look at that function, it's not like this, right? The normal representation is this. Why? Because the left-hand side variable is the variable whose behavior we are interested in. What variable are we trying to explain the behavior of? Quantity demanded, right? In the demand function, the variable of interest, the variable whose behavior we are trying to explain is quantity demanded, okay? So that variable is on the left-hand side. Then why don't we put it on the vertical axis then, right? It's because Marshall first drew the demand curve in the 1800s. This convention of putting independent variables on the vertical axis is from the 20th century, beginning of the 20th century. So it's like a clash of timelines, okay? So this one is called the demand function. The one that has P on the left-hand side or on the vertical axis is called the inverse demand function. So this is the inverse demand. Oh, you know what? I have a trick. Maybe it'll work. Okay. So you should know that this is the demand function, but it'll never be drawn this way. We'll always draw the inverse demand function, okay? So now remember the slope, when I wrote 1 over slope, that is the slope of the inverse demand function, okay? So here, now let's see, the slope of this function is equal to change in P divided by change in QD, okay? Whereas for this function, the number you are going to get is 1 over the slope, okay? So if you wanted to compute 1 over the slope for this one, which will have P on the left-hand side, and then QD on the right-hand side, right? It'd be like something like minus 3 QD plus 20 or something, okay? And so forth. This one, when you look at the coefficient of price, it's negative 3, right? But that negative 3 is 1 over slope. Why? Because for this functional form, change in QXD divided by change in PX is the slope, right? And what is it equal to for this functional form? It's equal to negative 3, okay? Why did I write that like that? Like that's going to cause confusion. This is for this one. Don't forget, okay? Visually. So now for this one, change in P divided by change in QD is equal to negative 3. Okay? They're inverses. So for this one, it would have been 1 over negative 3. Okay? That if I were to draw this one, it'll be like this. The slope will be negative 1 over 3. Okay? So if this was 20, this will have to be 60. Okay? Of course, for this one, it's not. It's 100. So let me draw that. It became like soup. You know, there's so many. Marshall, I mean, he lived before, I think, Frege or somebody who came up with the convention for the math. Just time soup. Okay, let's draw this one. Okay. Now, if we were to draw this with P on the vertical axis and Q on the horizontal axis, right? The 100, when P is 0, will be here. Okay? Because if you make everything else, whatever they are, forget about all these for a second. If you made this 0, you'll end up with 100 for Q. If everything else was 0. Okay? Of course, it's not. Like, we can give them different numbers. We don't have to give them all those variables the 0 value, right? Now, what will be here? If you take this to the other side, here Q is 0. What do you have? Oh, man. Please don't do that. Exactly. 33.3 bar. Okay? So you have to be careful with your demand functions. Now, this is just one demand function. As I put values for these demand functions will shift. Okay, here, this one assumes Py equals 0, M equals 0, Pax equals 0. If I change those values, my demand functions, intercepts will change. They'll keep shifting around. Okay, just be mindful. When you compute your elasticity values, don't make mistakes. So let's compute the elasticity value, let's say in the midpoint, right? What is the midpoint? 50 for this one, when all the others are 0. This will be 100 over 6. It'll be half of this, right? So first, we have to get the slope, right? And we already know the slope, though. Or actually, in this case, we have to get the slope. Okay? Remember, what is the price elasticity of demand? It's 1 over slope. But whose slope? The slope of the inverse demand function. Okay? Or you can directly take 1 over slope from this guy as -3. Okay? Because if you take 1 divided by -1 over 3, you end up with 3, like this guy. Okay? So be mindful. This is very tricky. Times P over Q. And let's say I'm computing it at point B again. Of course, you already know the answer, right? It's going to be -1. But I'm just illustrating it, you know? So here's what you need to do. You can write 1 over the slope of the inverse demand function. And what is the slope of this guy? -1 over 3. Okay? Times P over Q. What is P? P is 100 over 6 divided by what? 50. Okay? So let's go here. Out of space. I wonder if this is like, oh, that didn't work well. Now, so this becomes -3, right? And if you do the math, this will be 100 over 300. Okay? So that'll be 1 over 3. So what do you end up getting? -1 as expected. Okay? You have to be very careful. This could be very tricky. Now, this number, when Q, X, D is your dependent variable, represents what we called 1 over slope in the original elasticity computation. Okay, you can directly put it as, instead of doing this, you could directly put it in as -3. Because all you are doing is like converting it back to the inverse demand. You don't need to. You could directly take -3, put it for 1 over slope. Okay? And then multiply for the point you are given the P over Q ratio. Okay? Now, of course, here you can compute the cross price elasticity, right? If you want to compute cross price elasticity, you have to look at the change in the price of Y. The slope for that is given here. So you don't have to put 1 over slope, right? Because it's the inverse function. Of course, this is the direct function. This is the inverse function to keep the terminology the same. So you multiply 4 by whatever point you are computing it for, okay? And if you wanted the income, directly take the coefficient. You don't have to do 1 over slope because that's directly 1 over slope. You put negative 0.01 for whatever income, corresponding to that income is a quantity, you put it directly in, okay? You have to be careful. It's a nice exercise. It's very easy to confuse things. Like you have to always stay on top of it. Now, elasticities for nonlinear demand functions. Here's a trick we do, and I'm going to talk more about this when we talk about regressions. Now, to linearize a nonlinear function, we use natural logs, the ln function. How many of you have seen or heard of natural logs? Okay, so we use them as a tool to linearize nonlinear functions. Okay, you know, natural logs have these nice properties. So if you estimate a natural log regression, double natural log regression, what does that mean? Or dual natural logs? That means all your variables are converted to natural logs. Now, how do you do that in Excel? Let me show you how you will do it. Of course, you don't need to do it. You know, if I gave you a project, you might do it. But in general, you don't have to. But just to illustrate, I'm going to show you how to do it in Excel. Your homeworks are not asking you to do this. So you go to an empty cell. Let me say there's a data, right, on my like QX and corresponding PX. Okay? When QX is, let's say, 20, PX is 10. Now, how do I convert these to natural logs, right? So ln QX and ln for natural logs, ln PX. So what is my, gravity always works. Okay, against me sometimes. So this will be ln, where's my, even better. Okay, so where is my QX value? It's in A2. So I put A2 for those of you who have used Excel before. That's it. The natural log of QX being 20 in this case is 2.99, almost 3. Okay? Minus 3 decibel. Have you ever heard that rule? Like every such and such. I'll talk about it after this thing. It's a very common rule in science for people who study sound and electronics. Okay, equals ln false information for that side of the. I don't think there are engineers on the other side. So this is 2.3 for 10. Okay. So that's how you do it in Excel. Just I want to illustrate. Now, how am I going to compute elasticity values in this case? With double natural log, you're super lucky, actually. I could do some algebra and prove this to you, but that'll be like feeling like this once or twice, maybe. Now, and it uses some calculus. If not, it'll be even harder. I'll be using difference equation. So when you have a natural double log regression, the coefficients are automatically elasticities. So the price elasticity of demand in this case is actually equal to negative 1.2. Okay, you don't even have to work for it. It automatically gives it to you. The cross price elasticity of advertising. Remember, this is, let's say, advertising on good Y, another good, is equal to negative 2. Remember, you know, so the good is a substitute, let's say, and so forth. Now, how do I use that? Let me show you. Let's say the coefficient here is negative 1.2. And what is that? That's my price elasticity of demand for good X in the dual regression. Now, let's say this person wants to increase, their, let's actually write what it is. Quantity demanded, of course, by definition, percentage change in price of X. Quantity demanded of X, this own price elasticity of demand. Let's say this person wanted this to be +6. Okay, +6. They want to increase their quantity demanded by 6%. They want to sell 6% more product, right? What kind of a price change do they need to make, right? So they run this regression, Excel, and I'm going to show you how to do this in Excel too. Excel gives you this regression from your data, right? With the transformations you did, and then you go to the tool pack, it gives you this. What kind of a price change do you need to make? Let's compute, okay? So in this case, the percentage change in price can be computed as the percentage change in quantity demanded divided by the price elasticity of demand for X. In this case, it'll be +6 divided by -1.2. That gives you -5. So if you want to increase your quantity demanded by 6 percentage points, what do you have to do automatically? You know, you have to cut your prices by 5%. 5%. That's the beauty of it. Like, you know, if you have data, you compute this regression, you know your price elasticity of demand is automatically the coefficient for the own price elasticity. And you have a goal, right? Excel gives you this from your data. You want to increase your quantity demanded by 6%, right? It's just your goal. You want to sell 6% more. Let's say you expanded your shop such that you can sell 6% more. What kind of a price change do you have to make? This will tell you. In this case, what kind of a price change do you have to make for your product? You have to cut the price by 5 percentage points. Okay? It's a very powerful tool. Of course, you can do it like for like rainfall in this example or other things like, you know, whatever elasticity you're dealing with. In this case, the elasticity quantity demanded for rainfall is equal to +3. Okay? You can use that to compute how much you have to change quantity demanded by. In this case, by 30%. Okay? Or a 10% change will lead to a 30% change. So if rainfall increases by 10%, you'll have, let's say, 30% more produce. Okay? Regression. How do we do this in regression, right? We just said, you know, now in regression, let me show you in Excel how you will do it. So you'll be given data, right, in the first two columns like this. Then you'll convert it into natural log data, okay? Then you're ready to estimate your natural log regression. So the data, original data will be given to you as levels, okay? And then you convert them into natural logs. What is the next step? You go to the data tab, and I hope they installed it here. You go to the data tab at the top, okay? And you go to, in this case, they have not installed the data analysis tool pack because this is just, nobody taught that here before, but this is how you install it. You go to more, you go to options under Excel, and it's a free tool pack. Anybody who has Excel can install it. You go to add-ins, and then you choose the data analysis tool pack. You say, don't hit OK, hit go. Then this screen comes, choose everything. Okay? Then hit OK. Okay. Now, if you go to data, now you have the data analysis tool pack. Okay? You click on it. You go down to regression from this table, from this window. Okay? Click on that. Now you have to put your input data range. In this case, I'm just going to show you. In reality, you know, it won't be, actually, you know what? Let me cancel this. Let me make up some data. Okay? Let me come here so that we can actually estimate it. Okay? So here's quantity. Let's say I reduced my quantity to 10, and then as a result, my price went up. As my price increased, my quantity went down. That's the causation. So let's say this was, when price increased from 10 to 30, quantity went from 20 to 10. It decreased. Now I can copy, paste this into the next to compute the corresponding. Oh, I didn't mean to do that. Okay. Okay, so these are the corresponding I don't know why it did that. It's like Excel is like a different type of being. So that's in B. Thank you. Okay, so here's my data, right? Let me double check if this one is correct. That is correct. Okay, this is correct. Oh. So that is B2. Let me correct that. How did I miss that? Okay, so now I have my data, right? Of course, I have just 2 data points. That's like just not going to be the case. When I give you data, it's going to have at least like, I'll say like 75 observations, let's say, or like 50 observations. So I go to my data analysis toolpack. I go to regression. I click OK. Where's my Y? Now, my Y, I'm interested in explaining the behavior of quantity, right? So what do? I write here. I can do it in many different ways. I could just directly come here and do this, okay? And then I can put my X range in. Now, do I want my constant on the regression line to be 0? No. You would want to do that for some scenarios where otherwise it wouldn't make sense. Okay, I'll give examples to those if need be. Now, you don't have to change anything else. You just click OK. It gives you 3 outputs basically. One is the summary output showing how good a regression this is. You know, like 1 is like an extreme value saying this is a perfect regression, but in reality, there's not enough data. Okay. Now, and then the analysis of variance. Here, the important value is the F test, not enough data. But here, the important values are the P values. We want those to be close to 0. And your elasticity in this case, price elasticity of demand is negative 0.63, which makes sense because the demand curve is negative slope, right? So if I were to write this equation, let me show you. If I were to write this equation, my equation will be like this. Q D X equals some constant. In this case, what is the constant? 4.48502 minus 0.63093 px. Okay, that's my regression output. Now I know what is this. This is my, or one. It's actually the elasticity, the whole elasticity. Normally, actually, you know what? Thank you for saying that. I have to put the lns, okay? Of course, I want you to know those are the lns, okay? I wrote them as not lns, but these are these, right? Like my variables are those, okay? So this is my elasticity value directly. So it's 0. So it's price elasticity of demand for X. What is it equal to? Negative 0.63093. Don't forget, the data came from natural logs, right? It might be good practice to write the natural logs when you write your data. If you don't, keep it at the back of your mind that that is the case. I'm so glad you said that. Okay? Never forget what you're dealing with. You don't have, this is not slope. This is already elasticity. Why? Because our data was double natural logs. So if you estimate in levels, you have to go through computing it as 1 over slope times P over Q. If you do it as double natural logs, it's automatically elasticity. Did everybody follow that? If your data are in levels, your quantity demanded of X and PX, or remember like in the Excel, the first 2 columns, let me go back in sheet 1. If I directly use these as my data, right, in my regression, the coefficient here will not be elasticity. It'll be just 1 over slope, or it'll be slope in this case. Actually, it'll be 1 over slope. Since this is inverse, it'll be 1 over slope. But if I use natural logs for price and quantity, my coefficient is already elasticity. You don't have to compute anything. You're automatically going to be given elasticity. Okay, don't forget that. Okay, where are we? Same, we just did that. Now, for your regression, you want these p-values to be very small. If the regression does not give you very small p-values for the coefficient or the elasticity value in this case, your variable does not do a good job explaining the change in the dependent variable. Okay, you should use a different variable. Of course, in this case, automatically you expect it to do a very good job, right? Everybody cares about price when they make their decisions about quantity. Price is the most important variable. And you can see that here, right? We want this number usually to be at least less than 0.1. In this case, it's even less than 0.01. Okay? So this is a really good regression. Of course, you can also see the R-square value here is 0.75. That is, the closer that is to 1, or the more that is like more than something like 0.5 or 0.6, that also indicates it's a good regression. And then you can, if you had more than 1 independent variable, here we do not, this F value becomes important, okay? You want the significance for that to be also small when you have multiple values, okay? In this case, we do not. And as you can see, the 2 values are the same. They need not be. They'll be different when you have more independent variables. The reason they are the same is because the F becomes the t-test when you have only 1 independent variable. Okay. We just talk about R-square, the F-test, and all that. Now, nonlinear functions use natural logs to linearize, and then you get your Excel output, and then you interpret. Now, this is a nice data set because it's using more than 1 independent variable. There's price, there's advertising, and there's distance. And let's write that function down. Okay, now, so ln q d of x equals 135.15 minus 0.14 ln price of x plus 0.54 advertising on X minus 5.78 ln. Of course, this is also ln, my bad. ln distance, okay? That's my regression equation. Now, let's look at the p-values. Which variables are doing a good job? Price does an okay job. It's like 0.05, which is less than 0.1. It's not as good as 0.01, 1% level. Price is doing an okay job explaining the variation in quantity demanded. It's an important variable. Now, advertising, on the other hand, is much larger than even 0.1. advertising for these demanders or sets of people participating in the market as consumers is not doing a good job at all. It's an unimportant variable. Okay. How about distance? Does distance play a big role? Yes, it actually plays a very significant role. These consumers really care about distance. Why? Because look at like the t-stats is really significantly different from the critical value as indicated by the p-value. This p-value is way less than even 0.01. Okay. So distance really matters, price matters, advertising doesn't matter. Okay. Now, what is you tell me. Let me ask you questions. What is the price elasticity of demand for X in this case? Yes, sir. You don't have to compute any slope or anything. Why? Because this regression is in double natural logs. Both sides are natural logs. Dependent variable is in natural logs. Independent variables are also in natural logs. If you didn't transform your data, you cannot do that. You will have to play all these tricks we played before. You'll have to compute it as 1 over slope times whatever point you're interested in. Here, you don't have to care about points. You automatically get your elasticity value. Okay? So what is the advertising elasticity for demand? Jefferson, what is the advertising elasticity for demand? It is equal to 0.54, right? Why is that? Because that's the coefficient for advertising, and my regression is in double natural logs. Now, what is the distance elasticity for demand? Negative 5.78. Now, here's a question again. Jefferson, which variable matters the most in this case for this demand function? Which variable matters the most? Distance. Why? Because it has the lowest p-value. It's the most significant variable in affecting quantity demanded. Okay, so those p-values, the smaller they are, the more significant the variable is, different from 0, meaning it is very influential in determining the behavior of quantity demanded. Okay, you want to see these values as small as possible. Now look at the R square, 0.79. Are these variables together, or if adjusted R square, 0.69? Use adjust R square because like we have more than one independent variable. And what is it? 0.69, right? So 0.69 is not too bad. These three variables together are doing a good job. But you can see that with the F statistic too. You know, like 7.59. I mean, 0.69 is not like 0.8, 0.9. It's not that close to 1. But it's not like 0.3 either. It's not 0.2 or it's not 0.1. You know, these variables together are kind of explaining 69% of the variation in the dependent variable together. But there are probably other important variables we're leaving out that are determining the other 31%. Now, look at the F statistics p-value, 0.182. Together, they're not doing a great job. Why? Because that's more than 0.1. We want to see that number less than 0.1. And 0.1 is a weak case. You know, if it's bigger than 0.1, it's not good. Where is really the bad variable? Advertising. We should have replaced it with something like income. That's more relevant, probably. You know what I'm saying? Every time you see a regression like this, you have to add other variables and kick out the ones that are not doing a good job. Okay, that could be like a project for this class. Now, we are finished.